Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on February 12, 2026, just yesterday. It introduces a framework called ExOPD that allows student models to effectively break the teacher ceiling, achieving about 45% math accuracy on small models where standard methods stall at around 43%. The paper is titled, Learning Beyond Teacher, Generalized on Policy Distillation with Reward Extrapolation. And as we'll see later, this approach of extrapolating rewards has some really impressive implications for merging expert models and strong to weak distillation. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 breaks down the method's effectiveness across two scenarios. On the left, panel A plots math reasoning against code generation. The pink star shows that ExOPD sits in the top right, which means it is the only method that outperforms the domain teachers on both tasks simultaneously. Moving to panel B on the right, we see strong to weak distillation results. Across both model sizes, ExOPD consistently achieves the highest accuracy, clearly surpassing standard on policy distillation. Figure 2 breaks down the math reasoning results by plotting accuracy against the reward scaling factor, lambda. On the left, in the reward interpolation zone, performance steadily climbs as lambda approaches 1, eventually matching the teacher's baseline shown by the dashed lines. However, the real breakthrough appears on the right, in the reward extrapolation zone. Here, setting lambda to 1.25 pushes the student's accuracy above the teacher's ceiling, particularly visible on the AM24 and AM25 benchmarks. To confirm the student's success isn't just due to the teacher being undertrained, Table 1 runs a control experiment. It compares ExOPD against a teacher that received continued reinforcement learning for 100 additional steps. Remarkably, even with half the training steps, ExOPD achieves a higher average score of 48% compared to the teacher's 46.9%. Moving down to Table 2, we see how this applies when merging multiple domain experts. In the multi-teacher distillation section, ExOPD stands out as the only method that improves performance across both math and code simultaneously, while baselines like SFT often regress. Breaking down the numbers, the middle section on single-teacher distillation highlights a key difference. While standard on policy distillation slightly degrades code generation to 60.8%, ExOPD improves it to 62.1%. This consistency is vital in the multi-teacher distillation section at the bottom. There, ExOPD stands alone as the only method boosting both math and code scores simultaneously, reaching averages of 47.7% and 62%. Well, besides merging experts, the paper also applies this to strong to weak distillation. Table 3 reports the accuracy when distilling a 30 billion parameter teacher into smaller 1.7 and 4 billion parameter students. In the middle section for the 1.7 billion model, ExOPD achieves 25.4% average accuracy, surpassing standard OPD by over 2 points. The bottom section confirms this for the 4 billion parameter student, where ExOPD hits 45.3%. This significantly outperforms supervised fine-tuning, which lags behind at 35.1%. Showing that reward extrapolation effectively compresses knowledge even across large size gaps. So Figure 6 investigates an enhancement called reward correction. This technique uses the teacher's pre-RL base model as the reference point to sharpen the reward signal during distillation. On the left, in the math reasoning benchmarks, adding reward correction pushes the accuracy to 28.7%, edging out the standard ExOPD result of 28.1%. We see a similar pattern on the right for code generation, where the corrected method reaches 52.3%, confirming that a better reference model can squeeze out further gains. Wrapping up, two big takeaways stand out. First, on policy distillation, is effectively dense reinforcement learning with implicit rewards. Second, by extrapolating these rewards, the ExOPD framework enables students to finally break the teacher's performance ceiling, offering a powerful new tool for model compression. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.